Hello students, and welcome to today's lesson over angles of elevation and depression. Our objective today is that we will apply angles of elevation and depression to solve real-world problems using our journal notes and a practice worksheet. First off, we need to define the angles of elevation and depression. So when we're talking about angles of elevation and depression, we're talking about the angles which an observer must change from their horizontal to view an object. So we're talking about a situation where maybe I've got a person here, right, and I want to figure out the height of this building, correct? So what I'm going to do is I measure the angle from when I'm looking horizontally or level to the plane, and then measure the angle which my head must tilt to be able to view the top of the building. So we see that the angle of elevation is that angle which an observer must elevate their line of sight to view an object. So they're changing their entire line of sight by some angle theta. The angle of depression is going to be something similar. So what we see is that it's the angle which an observer must elevate or must depress their line of sight to view an object. And these angles of elevation and depression are really useful to us because of one main reason. So we are very good at measuring small things, right? If I have something that's small enough for a ruler to measure, I can measure it very precisely. If I have something that's small enough for a tape measure, or so on or so forth. But what is very hard is indirect measurement. Let's say that you're trying to measure the height of a water tower, right? Or you're trying to determine how high up in the sky a plane is. Well, that's kind of difficult to do. You can't directly measure that a lot of the times without using some type of really high-tech technology. So what early humans did is that they were able to indirectly measure things using triangles. So knowing certain facts, they were able to measure other facts. For instance, for this angle of elevation problem right here, if you're looking at this building, right, and you're trying to determine its height, what you could do is first determine your own height, and then that's this height right here, and then you can measure pretty easily this distance here. And this distance here, you could just call it d, and what you'd find is that this x, right, this distance here would be x minus y. And what you determine is that you could find the height of the building just from this situation here. You don't even have to measure the building itself. What you're doing is you're using a trigonometric ratio, and because this forms a right angle, you're going to be able to find the height of this building. So that's pretty fascinating. Let's go ahead and move on to our next example, and we'll see exactly what this looks like. All right, so a lot of the times when we're using angles of elevation and depression, it will always be in a real-world situation of some type. So we're always trying to do some type of indirect measurement because we aren't able to take that measurement directly. So let's look first at an example of an angle of depression. So you're a pilot of an aircraft. You're trying to determine the distance from which you need to start your descent onto a runway at an airport. The tower requires that you descend at a maximum angle of 3 degrees. How far away must you start your descent to land on a runway if you begin at an altitude of 2714 feet? All right, so let's just go ahead and diagram this real quick. And we've already got our lines here. So we've got our plane. And you're the pilot, and your line of sight lies along this line. And what it's saying is that to land on the runway, the tower is requiring you to descend at a maximum of 3 degrees. So what they're saying is that your angle here that you can descend must be 3 degrees. All right, and you know that your altitude is going to be 2714. So we're trying to find the distance that we need to start our descent when we're approaching the runway. So here's an interesting thing. We've got a pair of parallel lines above and below. here, and here. Now, I also know this segment here. So, how am I going to find this missing side? Maybe alternate interior angles theorem, right? Because I have my parallel lines. So by AIA, I know that this angle will be 3%. So now I know this angle here, this is a right triangle that I've formed, and I know one of these side lengths here. So I know an angle, I know a side, and I'm looking for another side. It sounds like I'm going to have to use trig here. So let's determine which sides I need to use. Well, from my angle here, it looks like I've got my opposite side and the line that I'm looking for here is my adjacent. So I've got adjacent and opposite, so that means that I'm going to use my tangent function. So now I can come over here and say that the tangent of 3 degrees is equal to opposite over adjacent. So that's going to be 2714 over x. Okay? And we can do our little trick here where we just swap these two pieces, right? And what we'll see is that x is equal to 2714 divided by the tangent of 3 degrees. And what we find is that x must be about, I'm going to round it to 52,000 feet. And more precisely, it was closer to 52,786, but, oh, I'm sorry, 51,786. But it's okay to round it up a little bit here in this case because the number is so large. And it's going to be difficult for us to kind of gauge how far 51,786 is away. So it's okay for us to go ahead and round in this case. Wow, that's a lot of feet, right? Well, it's because this angle here, this 3-degree angle, is actually very small. So you're being forced to approach from far away because you can only go down so fast. So here's our answer here. All right, let's look at a similar situation when we are trying to determine our distance from a building. So over here I've got my little friend, we'll call him Bob. And Bob is trying to determine his distance from this tower. And this tower is actually going to be Freedom Tower in New York City. So what Bob wants to do is he wants to determine his distance. And so what he does is he knows that Freedom Tower is 1776 feet tall. It was designed to be that way. So he knows that about the tower, and what he does is he measures his angle from the tower. And what he finds is that his angle to the tower is going to be about 25 degrees here. And he's trying to find his distance. So again, we're going to use our tangent function here. So we have our tangent of 25 is equal to, again, it's going to be opposite over adjacent, so 1776 over x, and we find that x is equal to 1776 divided by the tangent of 25. And it turns out that he is about 3,800, and we'll call this 9 feet. So that's his approximate distance from the tower. Now, another great thing that we can do is this lets us measure objects which we don't know. So if I was looking, say, at another object, maybe a different building here, and I didn't know the height of the building, but I knew how far I was from the building, right? I was able to measure out how far I was. Maybe I moved like 400 feet away and take an angle. then I'm going to be able to find the height of that building using the same process here, correct? So our assignment today is going to be our worksheet that you guys picked up. So you picked up a worksheet and it was front and back and it's over angles of elevation and depression. So before you get started on that, well, actually, go ahead and get started on that and see if you can finish it. Once you've finished it, write 2 sentences describing what you learned today and your level of understanding of what we were doing today. If you have any questions, let me know, and have a wonderful day. Goodbye.